Okay, we are trying a bearing problem. Let's read it together. This is page 82, number 23 in your trigonometry textbook. Flying distance. The bearing from A to C is south 52 degrees east. The bearing from A to B is north 84 degrees east. The bearing from B to C is south 38 west. A plane flying at 250 miles per hour takes 2.4 hours to go from A to B. Find the distance from A to C. So it's very similar to the problem that we just did, except they give me no diagram, but I still want to figure out how far this thing is from A to C at the end. I would too. So let's see if I can get, there's a good amount. So let's see here. We've got a plane, the bearing from A to C. So let's start off with a point A. Well, from A to C is south 52 east. So,
First I do a dot line.
great idea. So when we're using method 2, we always start with the north-south line. Okay? C is south 52 east. So just put your pencil where you think that is, approximately, on your paper.
Let's see.
And then let's see if we all put it in the same...
And if it's going east, that's east.
Same as southeast.
Yep, it's south 52 east.
I have it like that.
So if you want to, again, this is page 82, number 23, if you want to follow along. I can't have the problem in the drawing on at the same time. But south, and then I want to go out about 52 degrees, right? I'm not, you can use a protractor. I'm not going to. I know if that's 90, right? Halfway is 45, so I'm going to go a little bit past there. All right, so I'm going to put my point C somewhere about there. But I know when I draw this, right, it's this angle off the north-south line that's 52 degrees. Okay? A lot of times kids mistakenly put this angle as 52. It's always off the north-south line. So I have north-south, and I went 52 degrees in the east direction. Okay? Now it says the bearing from A to B is north 84 degrees east. Okay, so now I want to go from A to B. So go back to A. North 84 degrees east. So north, put your pencil where you think north 84 degrees east would be.
You know, this is 90. Pretty shallow.
I'd put it right about there. Maybe I'm actually going to move the letter A to the other side, just so it's... Put my A over here. So this one, from A, I went north, and then I had to go 84 degrees in the east direction. So that right there is 84 degrees. And now I'm looking at my third part, and I'm realizing that I didn't make this long enough, because B to C is south 38 west, so I actually need B to be a little bit further out. So I'm going to move B to over here. There we go. No, sorry. So then the next piece that they tell me is that the bearing from B to C is south 38 degrees west. So I'm going to draw myself another north-south line through B. And in order to get from B to C, I have to go 38 degrees in the west direction. So see why I had to move it over here? Otherwise it wouldn't have worked out very well. But now I'm south and I'm 38 degrees in the west direction. So make sure you mark this as 38 degrees.
Outside angle?
Uh-huh. It's from the north-south line to the place that you're going. So that is, it's 38 degrees off the north-south line in the west direction. Now, let's see. So the next thing that they tell me, a plane flying at 250 miles per hour takes 2.4 hours to go from A to B. So from A to B, I'm going to do 2.4 times 250. I get 600. So I know that this is 600 miles. And I'm trying to find the distance from A to C. So I'll mark that as X. That's my ultimate goal. Now I have a good drawing. And now hopefully I can figure out some pieces here. I could certainly find this angle, couldn't I?
Yeah, you can find that. Just 180 minus 84.
Exactly. I know that this is 180. Let's get rid of those two and start with at least one angle in there and see where I can go from there. Might see. So this angle ends up being 44 degrees. Okay. Whoa, 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 whoa. I don't know that I have any right angles yet. I don't know that yet. Chances are, since the section title is Further Applications of Right Triangles, I'm sure that one might pop up somewhere. But I don't know where yet, right? Because remember, this is not drawn to scale, so even though this certainly doesn't look like a 90-degree angle, maybe it ends up being it. I don't know. I need the math to back me up. I claim, guys, though, I know this angle.
52, so that's it.
How did you get 52?
Alternate exterior. Alternate
To who?
to that one.
This one?
That one.
Mm-mm.
Interior.
Um,
I was going with 38.
well, here's what I do know. This one's 84, and it does have an alternate interior. Wouldn't it be this whole one? If this is 84, so would this be. So if this whole thing is 84, can't I find that?
Yeah, that's.
I would do 84 minus 38, and I get 46.
Oh, that's what I thought.
Now I can confirm if that's 44 and that's 46, this one has to be 90. But you can't just go around assuming, right? Especially when I'm not using protractors, I'm not drawing to scale. I have to make sure that my numbers back me up. I can't just pick someone to be 90. Now I should certainly be able to solve. I have several options now, don't I? Because now, really, you can forget all this other stuff and just look at the triangle. I have a right triangle. I know the two angles. This side's x and this side is 600. So I should be able to set up an equation to solve. I like 44. So if I want to deal with the 44-degree angle, what might I do? So that's cosine. Cosine of 44 would get me the adjacent over the hypotenuse. That's it. Do I hit second cosine? No.
You know the angle.
You know the angle. It's when you don't know the angle and you have the two sides. That's when you hit second whatever you're at. So there is my answer. It certainly makes sense given the problem, right? If that's 600, this side could certainly be 431. How many sig figs are we looking at? Just one? I think we have two, don't we?
2 for the angles, yeah.
Everybody's got two.
Except for 600.
Where's the 600? No, in the given problem. They didn't, I calculated that one. So, in what's given, I think I've got 2 and everything. So, then you would do 430?
Oh, but.
Yep. And so X is approximately 430 miles.
Would you look at that?
Mm-hmm.
Oh, boy.